Okay, yeah, wait, Ethan made it. Yep, Ethan made it. Yep.
Oh, Michael and Cole made like the table of contents, and they did most of it, or they did like half of it. And then I did
That thing is stellar.
I did like a lot.
Really well done.
Of course, it's already sort of broken.
Hey, you may use your notes for Jeopardy.
Okay, say that you when I'm gonna be on it, can you use that also?
Yeah. That counts as
No, we just borrowed your study guide for a second.
Hey, wait, is this recording?
Yep, for Alex. And is anybody not here?
Shannon!
Shannon.
Where's
Shannon?
I don't know.
Not here.
Yeah. Okay, I'm gonna hand back some graded stuff first before I forget, like I did with the other people. And then we will get started.
I thought they were tomatoes.
Okay, so I graded these last week. If anybody changed anything on any of these before Thursday, it's not noted on here. So that's cool. I don't even know where he's at. Oh, you sitting over here. This way.
Don't worry.
Come over to paper. Who wants the paper for awkward armadillos? You want it? Awkward armadillos. Who wants the paper?
That's probably be from go to Abby to do that.
Okay, and Fishman is you, right? Okay, and then baby. Me. Then
Let's go.
it's the girls. I think.
Well, I'm hungry, I just-
Nightmare stuff, my friend.
Alex. So last week's homework assignment, which it gives energy and stuff, like I said in the email, that was a bomb for most of you. I'll make a tutorial for it, but I need to get us through midterms first. That's so. That's cool. Hi. All right, that's everything I have. If you turn something in electronically, I probably returned it electronically.
I missed one of the tests on spasm in, paper, so I can give you a little song there. Oh, Shannon.
So what?
She missed a test that were on paper, so she could write song lyrics.
Oh, yes. I like that too, but you can still write them on your homework.
Yeah.
You can write them on your homework in your lab.
That's true.
Yeah, it's much easier to keep the tests online. I liked them on paper too, but it's so much faster. And there's so many more of you now. There were like 8 of you when I was doing that. Now there's 22. So there are 22 of you. All right, so here's what we're gonna do. 1, 2, 3, 4, 5. I'm gonna divide at Ethan. So Ethan to the west
Let's go.
is gonna be team 1. And Abby and Faith to the east is gonna be team 2. Now you need a team name.
Imagine being second.
That's the progress. My vote is awkward armadillos. Yeah, I'm trying to make good.
Miss Annie.
Yep.
You're not team 2. We are awkward armadillos.
So you're gonna be awkward armadillos 2.0.
We're a ball.
And what are y'all gonna be over there?
Yes.
I'm gonna put Shannon on team with awkward armadillos 2.
Let's go.
There are 3 members of awkward armadillos here. We are the dominant. We're the majority.
So, okay. All right, so listen up. Let me make sure that everybody knows what we're doing. I know. So what I'm going to do is we are going to play a Jeopardy, and we have Shannon with us. So the way we're going to do this is we're going to let each of you, listen, boys, guys, we're going to let each of you pick your, what do you want to call it, box, category, and dollar amount, right? And we'll go this direction for each group. Okay, so Shannon, you'll get to pick. And you can either talk to us or you can write it in the chat box. Now, the way I did this with the other group is the same way I'll do it with you. If you're the one that picked, I'm going to give you 20 seconds to answer on your own. And then I'll say team. And at that point, I'm throwing it to your team to help you in the remaining 10 seconds. After that, I'm throwing it to the other team as a whole, and they have 30 seconds. All right. And the way I did it with the younger group, I think I'll do it again. So no negative points. It's either you don't get it, you get 0 instead of negative points, or you do get it and you get positive points. Okey-doke. Does that make sense? So what were our team names? You had Awkward Armadillos Part 2.
Team 1.
No, we're team blue. We're team 2.
Come on. Why are we
What's your team name gonna be for this?
Team 1?
Why would we be team 1?
Because that's what you gave us.
No.
Like team 1 is the most descriptive name.
Awkward Armadillos 2.0, and you guys will be.
team 2.
No, we want team 1. Just
No, I hate team 1.
All right, exciting. Shannon, you're on Awkward Armadillos 2.0.
You could be team 1.5.
You should have been like blue or something.
You can change it still. We haven't started. You all right there, Cole?
Team Beluga.
What's the difference of team 1.5?
Team Beluga.
Yeah.
I think that's unnecessary.
All right, so we're starting with Sydney, which means Sydney is going to get. Sydney's so excited about this. So Sydney is going to get herself 20 seconds to answer the question on her own. Shh. And then I'm going to say team, and I'm going to toss it over there. Now, the way I did it before, Shannon, since you're here online, the way I did it with Jocelyn and Senya earlier is when I throw it to team, I'll give you a chance at the end to add something if they don't already have the answer, because otherwise you'll be shouting out the answer and you may help the other team. So you have a question?
What's the far right column?
Oh yeah, I'm gonna throw this down. So the far right column is laws. All right. So Miss Sydney, where do you want to start, friend? Oh, she's so excited. I've never seen her more excited in my life. Pick one, anyone. You can do it.
Let's bond.
Yeah.
You can do it. What is it? She's frozen. Just the basics? Is that what you said? Just the basics. I know you got her voice in there, gorgeous. Okay. Here we go. Just the basics for 100. She's going to get 20 seconds and I'll say team, and then the remainder of the team can help. If you give a wrong answer, I'm not going to say anything until you get the right answer or 30 seconds is up. Okay?
Guys, we just yell every answer we think of.
All right. In the mnemonic device, King Henry died unexpectedly drinking chocolate milk. The words in the phrase represent this list of metric prefixes. Give her 20 seconds. I know she knows it.
Nice job.
It's on the last page.
So
It
smooth.
didn't say anything.
Go for it. If you know it, say it.
Was Ethan on our team?
Yeah.
Yeah.
Thanks.
I wouldn't give it to her if I wasn't on
I
her
figured.
team.
Okay, team, your time's running, so you
Come on,
do it.
I have it. There you go.
You can read it. Just read it.
It's in the doc.
Voice.
Yeah, it is.
Okay, what'd you say?
Oh yeah.
Go ahead.
Somebody else can read it for her too,
I got it.
because I said team. So
Kilo, hecto, deca, unit, deci, centi, multi.
and bingo. Good job.
Oh,
Steve.
Did
Did he say multi? Oh wait, he said multi, not milli.
It's our turn.
Oh no, it is your turn. I already put it up. You already knew it. Michael,
Why did you
Michael.
do that?
Why you be like that?
All right.
You know the
Why is it doing that?
Oh,
Score for this team is not a number. You need to edit the score.
Because you're not actually getting any.
Okay, well, it doesn't like me to do that one, but whatever. Okay.
Actually, we answered.
So that was 100, but it doesn't want me to put it down.
Ready?
Huh?
Bounty point, milli is spelled with 2 L's.
Yeah, gone. All right, there
I
you
would
go.
argue that we should get at least half
It doesn't work that way.
because first of all, he's the weak link. Second,
He's the weak link.
Yep.
I'm the weak
Yep,
link. What are you
weak
talking
link.
about?
Yep.
That's my.
Why won't it let me put that in?
Yep.
Is it only gonna let me say no to that?
I'm the
And-
first one to answer the
Well,
question.
that's weird. It doesn't want me.
answered it wrong.
Technically. I need to dance over that.
Say it again. No, it usually lets you. Oh, I see. You're right. Wait. You're right. I put it in the wrong box. It's supposed to be in the box above it. Good call. I was like, why isn't this working? It worked before. Whoops. There we go. Good call. I was like, why isn't this going? I put it in the wrong box.
I said team blue, but everyone said no. So
Okay, so they got. Okay, wait. You got 100.
Beluga.
Then get it to go. There you
Just
go.
me, or is that team severely undernumbered?
Oh, come on.
That's 3.
Why are you not playing nicely? Okay, we'll have to add that in it. Maybe it's just let me do it because it's already there. Okay. All right. So Armadillos. Where are you going?
Faye, I think it's either your turn or Abby's turn.
It doesn't matter.
Abby, where do you?
Go
want
for it,
to go
Abby.
for?
Just the basics 300.
Just the basics, 300. A hypothesis is an idea that must be repeatable and that can be tested. Testing a hypothesis results in one of the two following dichotomous outcomes.
Supported and repeatable or rejected and repeatable.
Very good. Supported and supported and unsupported, or supported and rejected.
I don't think following should have a
Yep.
comma.
As long as you don't.
And I don't
No,
think-
it does, because these are all adjectives. To,
Man,
following, and
we're gonna have
dichotomous.
a party next
Oh.
week. We really don't
Oh.
need to bug her about brownie points.
He is all about the brownie points. So, yeah, I'm holding your midterm grade in my hand. Good. As long as you don't say proven or disproven. You can say rejected or unsupported, but you definitely should say supported and not proven. Okay. Coming back to you, Michael. Let's see. Hang on, let me make sure they got this right. All right. Oh, come on. Ugh.
Now we're up to 400.
It's supposed to add this for me. Why is it not doing it? That's supposed to just.
It's just being grumpy.
Okay, y'all are gonna have to remind me because I'll lose track of math. Okay. Alrighty, what's up, Michael?
Big ideas for 500.
Big ideas for 500. This is the experimental measurement of enthalpy.
No, I didn't. Yeah, it's that one.
Yeah, that's the device. How long is it? Yeah, it's with the wire.
Team, anybody wants to help him?
Is it calorimetry? What is calorimetry?
What is calorimetry? Very good. Yes.
Theoretically, I'm the strongest link because I'm the one who's answered correctly.
Alrighty, 500 to you.
It wouldn't be theoretically, it'd be statistically. So you are the weak now. So it would be.
All right.
Statistically be the strongest link if you did.
Don't worry.
So, Alex, where are we going, Alex?
Wait, let's bond 500.
Let's bond. Oops, sorry. Get this out of the way over here. Let's bond. Come on, go that way. Let's bond for 500, you said?
Yes.
Alrighty, here we go. Percentage yield is determined with this equation.
Oh, that's actual yield divided by theoretical yield multiplied by 100.
Outstanding. And that's 500 more points for these dudes. Nicely done. Actual. Now remember this is one that tripped a lot of you guys up when we did the chapter test. A lot of you were getting confused between theoretical over actual or actual over theoretical. Remember, your actual is always going to be smaller. So you want that on top because you're dividing into the smaller number because you are dividing your whole into the part instead of the other way around, and then multiplying by 100, and that's how you get a percentage. Okay, okay. Next up is Cole. Where are we going, Cole?
Oh boy. Just the basics for 500.
Just the basics for 500. Y'all going for the big questions. The scientific notation for this number.
1.23 times 10 to the 8.
Yeah.
Boom, nicely done. 500 for your team.
I think it's Jack.
Excellent. All right, Jack.
Like really hot.
Come on, Jack, you can do it.
Just the basics for 400.
Just the basics for 4.
I don't know why I didn't
A description of how close a measurement is to its actual value.
I know this one.
Accuracy and
Oh, accuracy. She has it.
I was supposed to let you keep answering, but it was just too funny not to quit.
They got multi-million when we got wrong.
I'm not going to count it against anything. Well, actually, I will count accuracy because you knew it. You were yelling
Yeah,
accuracy beforehand.
is how
So
close the measured value is to the actual true value.
Yeah.
Precision is how close the measured values are to each other.
We need to be up an additional point. 900.
I'm sorry, did you not say we weren't doing negatives?
no. Oh, wait, what did I just add to? Shoot, what was your score before? 900 plus 300. That's what I'm messing up. Okay. Okay.
That sounded like confused as you do.
No, I was.
Yeah.
It did. It did. That was funny. All
I'm
right.
confused because what is the accuracy? Why didn't we get hecto, kilo? No.
Because by then your time was up.
Yeah, that was the difference. The time was still going.
All
right. Ivy, you're up.
Okay. Discoveries for 100.
100. He is credited with having created the first modern periodic table.
Yes,
We're gonna wait our 20 seconds.
I think it's like the coolest thing I've ever seen.
How did I see that? Dimitri Mendeleev.
Yes, Dmitry Mendeleev. Very good. Very good. Very good.
Oh, thanks for getting us.
That one was 100, right?
Yeah, you.
We did it all, she did it all by herself.
All right.
Bailey, your turn.
Okay, Bailey.
Let's go, Bailey.
Shannon, you're next if you want to go. All right, Bailey, you're up. Next on this team.
Okay. He knows it. He knows it. Go for the big numbers. Go for the big numbers. Big numbers.
Okay, I'll do discoveries for 500.
Discoveries for 500. This is derived from the average mass of an element's isotopes weighted by the percentage of their abundance in nature.
Oh,
I think I know this one.
She's thinking,
Well, at least look it up in your notes to make sure. 'Cause we don't want to know the situation. Okay, I understand. Okay. You got some.
At least you got the point.
I know what it is. I think I know this. You know what it is? I think. Yeah, I don't know what this is. I don't think this is on our study.
okay, now we're at
I
team.
believe that it is the AMU.
There you go. It is the atomic mass. So yes, very good. Remember that the way they came up for that number for each of those elements was by taking your isotopes and then weighting them by how often those isotopes occur in nature. So if you've got more of one isotope than another, it's going to contribute more value to what they're guessing that number is. All right, so Kai is up next.
Give us our point.
Oh yeah, what was that? 500, so you're at 17. All right, Miss Kai, where are we headed?
I'll do big ideas for 400.
Big ideas for 400, team 1. All right, Kai. This is the energy as heat needed to raise 1 mole of an element or compound by 1 Kelvin.
I know this one.
I know.
Wait, she can't help you yet. She's got
Yeah.
10 more seconds on her own.
Is it molar heat capacity?
Hang on. She's got 10 more seconds on her own. Okay, now we're on team.
JK for mall.
What are you guessing, team? Everybody's yelling something.
JK for mall. Molar heat capacity.
Yeah, we're gonna go there. There we go. Molar heat capacity. Nicely done. Nicely done.
Why did you do that? That was
You're
so
good.
scary.
Which one was this? 400?
Yeah.
Okay, so we're over here at 15. All right. All right, Shannon, do you want to pick one? I don't know if you want to pick one or not. Oh, yep, she's here. Yep, she's in the chat.
Big number.
She wants just the basics for 200. All right, I'm going to give you in the chat 20 seconds after I read it for you. Okay. Look at this. Hang on. In an experiment, this variable is the one you change. All right, you got 20 seconds, Miss Shannon, and we'll toss it to the team. Just thinking.
Is it a change?
Wait a minute.
variable?
It's not your turn.
Hey, man.
All right, team.
It said change.
Yes, that's what I was gonna guess.
No, that's what I was gonna guess, because you were gonna let me guess.
In an experiment, this is the variable you change. You have 3 seconds, team.
She put it in.
She put it in. Where'd she put it in?
Independent.
Oh,
Right, just face it.
Yes, you got it, Shannon. She did it. Excellent. I didn't see it pop up. Usually it goes ding, ding. All right, there you go. So there is your answer. Your independent or manipulated variable. Very good. Your dependent is what changes. Your control is what you keep the same. Nice job, Shannon. Okay. And that one was 200, right?
Yeah.
So you're at 19. Let's go on to, all right. Ethan, where are we heading, friend?
Let's do laws to 500.
Yeah, laws.
Laws for what?
500.
You want 500?
Yeah.
All right, here we go. The law that states two or more elements which combine separately with the fixed weight of another element are either the same or simple multiples of the weights of the elements when they combine among themselves.
I know, I'm trying to figure out what.
And you got 20 seconds on your end. These might be presented like matching questions on your test. Just saying.
Question, are we allowed to do Jeopardy music for the other two? Because that's my favorite song.
Back when we were even playing Jeopardy, it was just sad.
Oh, team.
No, Rick Alex
Team.
Trebek.
I know that was
Team
sad.
is reciprocal law. Reciprocal proportions law.
Is this okay? Time. Is that what we've decided?
Yeah.
Okay, let's say we have the law of reciprocal proportions. 500 to team one. Oh, I have to move this. You're at 2,000. Look at you. You just passed them. All right.
At that point, I was just like, I don't know what it is. I might just let it go to team because Michael squeaked out that he's.
All right. So do you want to try one or do you want to pass it to Abby? Okay, Abby, you're up.
It's like a weird Scooby-Doo character.
Laws for 400. This law states that if two elements combine to give two or more different chemical compounds, then the weight of one of the elements, which combine with the fixed weight of the other, always show the numerical ratio to 1.
What's it called? Law of
Anybody agreeing, disagreeing?
Well,
We're allowed.
Team?
we're allowed to keep guessing, right?
Team?
Even if she gets it wrong.
Yeah, team go, team go, team go. I don't know yet.
You just looked questioning, like you were questioning it.
Gaseous volume, there's reciprocal, there's multiple, there's conservation of mass.
So reciprocal's already done.
I think it's multiple.
She had, yeah, you had it. Everybody just kind of had a look like,
Like,
do we really mean it?
overthink this for a minute.
All right, yes.
I thought you said you were gonna let us have it.
Oh, wait, you didn't look like you knew it, so I was making sure you were there.
It sounded like
Got
the
it.
one, but a little different.
That one was how many? 400.
400.
So now we're at 23. All right.
The reason I overthink.
You gotta
is
add
like
points while you're
conversations
still
with
in the
people who
page.
don't think.
Yeah, it wouldn't let me do that either. I don't know why. So usually you just click plus and it adds it, but it wasn't doing it. So, all right. Where are you headed to? Sydney, you're up again. You want to fit?
Sydney.
You
can do it.
400.
You can do it.
You got it,
Pressure
girl.
Sydney.
Never pressure Sydney. She works well, not under pressure.
That's very true. Everyone back off. Pretend we're not here.
Yeah.
Hey,
This is rude.
It's like jangling your keys when the other team is about to, sorry, football things. You know, key five. Discoveries for 400. Okay. In 1865, John Newland arranged the known elements by property and by order of increasing atomic mass. He noticed that patterns repeated about every 4 elements. This is what he called that pattern.
I think I know this one.
Oh, is that
Wait a minute, it's Sydney for a couple some more seconds. Let her think. All right, team.
What?
You know. What's this thing?
No, we only have the current case
What?
on zero two.
Yeah, dang.
All right, pass to the other side.
Periodic table.
Is that your answer? This would be the law of octets.
I don't know how to
They
say
didn't
that.
get it, we didn't get it.
Law of octets.
We embarrass ourselves with that.
You remember we had the whole like, oh look, this lesson's musical. Even, yeah, remember? Yeah.
Well, we did.
Yeah, octet rule, law of octets. If you see it, just know that Newlands goes with octets. That's what you need to know. If you know Newlands goes with octets, you're going to do fine.
Let's bond for 400.
Let's bond for 400. Okay. This is the type of reaction in this type. Okay, I didn't get to finish it, but that would be correct. So there we go. All right. That was 400, you said, yeah?
Yep.
Okay. And now we'll just go back to the other team, I guess. Okay.
2 seconds.
What would you like, guys? Michael, you're up.
Discoveries for 300.
Discoveries for 300. He envisioned atoms like small marbles.
Oh, I know this one.
John Dalton.
Who is John Dalton?
Nope.
Who is J.J. Thompson?
Nope.
Okay. And it's not Niels Bohr.
Not Niels Bohr.
Yeah, those are the three I have for.
Team?
Einstein.
It wasn't Einstein.
Start naming people.
Oh, and we embarrass ourselves.
And over to the other team.
I was saying
30 seconds. Who?
BROGE. I don't think it's him, but
Nope.
Ernest Rutherford.
Not Rutherford.
I just looked down and there's this really cool picture of
Aristotle.
You're getting closer, but your team's already up.
Shakespeare.
Shakespeare.
it was
The guy who came up with the term for atoms to begin with.
That's Dalton.
You Google it.
Nope.
I swear to God.
It's not Dalton.
Google is my friend, okay?
And our answer is
I Googled it.
Democritus.
Close.
You were closer. You were at least hitting ancient philosopher types.
I
Yeah,
was
there you
sitting
go.
in philosopher.
Ancient philosopher types. Okay, yeah. Okay. Resetting our timer. Moving back to who is it? It's Alex's turn. No, Jack's turn. Alex was a 2-second question. All right, Jack.
Come on, Jack, get that Dr. Pepper.
What are we going for? Yeah, he's fueled up on the Dr. Pepper. He's ready to go.
Let's bond for 300.
Let's bond for 300. This bond occurs when electrons shared by two atoms are held more closely by one atom.
I got it.
Great.
Hang on, he's got 20 seconds.
The suspense, okay? No.
Oh, gross. I hate them. Don't smash it. We'll all regret it. And team.
Quadrivalent.
All righty, there we go. Polar covalent. Very good.
I was just like waiting.
Covalent, because it says shared. Polar, because it says more closely to one side than the other. Right, Shannon has a chat. Wait, what'd she say? She was yelling John Dalton. Sorry, it's so hard to read it. Sorry. It's hard to read Shannon typing while watching all your faces going up. He was in your notes and
I put it in there now.
and head back. All right, now where are we headed? Cole.
Big
Give us
idea.
our points.
Oh, I'm sorry. What was that? 300.
Hey, please and thank you. Go
3,000. Okay. Cole, you were going where?
Do big ideas 300.
Big ideas, 300. Are we ready, team one? Okay. Cole, question. Your answer is a substance which undergoes a change in a chemical reaction.
Substance combination. Reactant.
There you go. Reactant. Nicely done. Very good. Very good. That was how many? 300?
Yes.
Okay. All right. So who was it? It's Bailey, right? All right, Bailey. Where are we going?
Let's see, Michael.
Whoop.
Let's go, baby. Let's go.
Where are we going, Bailey?
Okay.
B.
Bailey, pick one.
B.
I'm going C for B.
Pick one that you want. Don't listen to him.
Next for the square root of
Okay,
one.
so bad.
He's like,
Pick up this.
A7. Did I see your battleship?
Let her pick.
Are you doing like battleship over there?
No.
She said discoveries for 200.
What'd you say? Discoveries for 200. All right, Bailey. Credited with creating the first atomic theory. 3 of his 5 points are still accepted as true today.
Okay.
She's thinking, she's thinking. No team yet. 5 more seconds till team.
Okay, I can think.
All right, team.
John Dalton.
Sean Dalton would be right. And you know what Shannon was saying? What were you saying, Shannon? Shannon was saying,
Dalton.
is this John Dalton? Because she tried that the last time. Yeah, yes, you are right. It is Sean Dalton. Very good. All right, excellent. And that was 200, right?
Like Andy Dalton, but it's John Dalton.
All right. So who's up? Ivy is up. All right, Ivy, where are we headed?
How about laws?
300. Laws. Okay, Miss Ivy. This law states that when gases react to give products under the same condition of temperature and pressure, they react in the simple whole number ratio by volumes. 20 seconds on your own. 20 seconds on her own. Wait a minute. Let her go on her own first, Michael, and then don't help till you get to the 22nd point. What'd you?
Not telling her.
Hang on.
I know, we will once it's our time.
All right, team.
Law of gaseous volumes.
Law of gaseous volumes is going to be correct. Very good. And that one was what, 4? Was that 400? Very good. All right.
No, that's 300.
Was it 3?
3.
I thought it was 4.
No, it says 3 at the top. It says 3.
Oh, it does say 3. So wait, where were we? We were at 26. Yep, you're right. It was 3. Yeah, you cheaters. Okay.
You cheaters.
Trying to tell her it was 600.
All right. Who is? Whoop. It's Shannon's turn. Yes. Okay. So let's see what she picks. Shannon.
Or do you want to give it to someone else?
No, we'll give Shannon a chance. Big idea is 200, Shannon says. All right, we're going to give her 20 seconds to answer. The name given to the vertical divisions of the periodic table.
Yeah. I get it.
Give her time.
Group. Oh, she got group.
Yeah, she got it. Good job. Nicely done, Shannon.
Wait, is she on our team?
No.
Dang!
Kai was so excited. Is she on our team? No. All righty.
You gave us our point?
I did. All right. Now we're back to Kai. You're up.
Laws, 200.
Laws, 200. This law states that a pure chemical compound always contains the same elements combined together in the same proportion by weight whenever, whatever may be the method of its preparation or whatever may be its source.
Okay, I know this one.
I'm gonna take 20 seconds.
Are we
to figure
gonna
out.
click for it now?
Yep.
Exactly 20.
Taking her 20 seconds to think.
Can you stop?
You are really easy.
The other one.
I'm on your team and you're starting to get annoyed.
Team.
Is it sausage portions?
There we go. There we go. Very good. Excellent. Excellent.
Wait, Michael, where are the laws on the study?
They are.
Why don't we have them?
That's hilarious.
Okay, so I'll work on that thing out.
If you look in the stoichiometry notes, those are basically your 5 laws of stoichiometry, the stoichiometry notes. There was a lesson on
We have the laws.
in the PowerPoint slide, y'all, it was like a picture of the scientist. It was black. Do you remember that? The screen was black.
Yeah.
There's a picture of the scientist and then the law. That's the one you're looking for.
Of course.
Okay.
You're throwing. It was not.
All right, so we're
Throwing.
hold on, wait. It's getting too noisy. Cole, Michael.
I also have 2 questions. One,
Yes.
is there a daily double in this?
No, I didn't get that
And
far.
is there a final Jeopardy?
Yeah, I didn't get that far either, but I may throw one out.
There's only 25.
All right, what'd you say, Abby?
Let's want 200.
Let's bond 200. Okay, a bond in which 2 atoms share electrons.
She said covalent.
There you go. You got it. Easy. That was an easy one, right? Excellent. So that one's 236. Excellent. All right. Where are we going, Ethan?
Let's do big ideas 100.
Big idea is 100. This is a measure of the amount of order within a system.
Oh,
Yeah, stupid.
oh, yeah.
Final Jeopardy though.
I can throw out a Final
If we
Jeopardy.
don't do Final Jeopardy, we already.
I can
have it.
totally throw out Final Jeopardy.
I'm gonna wait 20 seconds because I don't think I got this.
Because
We are.
they would be 500 points behind if they got the rest of these.
I know.
Yeah, we got this. But then we just need, because then we.
Okay, team.
They're gonna wager.
Team.
all of the stuff.
Enthalpy or entropy?
Entropy.
You guys got to pick.
It's
No, we don't.
TR.
Time.
Entropy.
No, we don't.
Who said?
If you answer wrong, you just do nothing.
Yes.
You got it, Cole. All right. You had to pick one or the other.
No, we don't.
All right.
I'm not. I'm not.
All right, where are we going, Alex?
Alex, let's bond 100.
Let's bond 100.
Yeah, right.
These compounds have crystallattice structure, and he's right already. Nicely done, Ion. So
So 2 seconds.
he's very fast at these. All right.
It is a crystalline.
All right, so this is all that's left for you guys. Are you ready? You can all answer. It can be a team effort because this is all that's left. This law states that the total mass of a reactant undergoing a chemical reaction is always equal to the total mass of the product in a chemical chain.
Now they just have 30 seconds.
Yep, they have 30 seconds.
Conservation math.
No, because that doesn't involve. It didn't say chemical.
Really? Don't steal my
Well,
thunder.
what was the other proportion for? Relative?
Have we done fixed yet?
Fixed proportion?
Yes,
Yeah.
yes.
Constant, you did, yes.
Total mass of the relative.
We've done relative, right?
Total. It's not.
Yeah.
You did
we
reciprocal.
don't know this because
And
we have laws, 'cause they wasn't-
Over to the other side.
Law of conservation of mass.
That is the law of conservation of mass. It is. This is the law of conservation of mass written from a chemistry
Oh,
perspective.
got it.
So you guys would probably state it as, wait a minute, Cole, how would you normally state it?
Mass cannot be neither be created nor destroyed. Only with a transfer. No,
It
not
only
energy, sorry.
change
Only change.
form.
sorry.
Right. So, but if you look at this, it's the same thing
It
broken
looks
down to a
like it,
reaction
yeah, I
level.
just-
Yeah, you thought about it and then you second guessed yourself. So remember that law of conservation of mass is the basic fundamental law of all chemistry, and that from a chemical perspective, this is the way you'll see it, right? Okay, so I will throw out a final Jeopardy. Let me see here. I'm going to
You should make one more question that's just a winner takes all question.
stop my screen share for a minute, huh?
We got our points.
You won.
The last one, no, the last one. It didn't matter though, yeah, you totally won.
Jeopardy, you might win, though.
38, okay, 2,900.
Yeah, all you're getting up.
So we are 2,900 to 3,800, all right? So I'm gonna give you, get this off. All right, I'm gonna give you now a final Jeopardy question. And as a team, whoops, okay. As a team, you're gonna have to figure it out. Okay, let me pick a really good one.
Yes, but Final Jeopardy.
Let me pick a good one.
We just need to get 100 points more than them. This is how much-
All right,
Look like a.
so I'm gonna give you 30 seconds. Have your wagers ready. Write your wager on something. Write it down so you can't change it.
No, if you look. No. I think I know what it looks like.
Does everybody have their wager written somewhere so that you can't fake it later?
All in.
All in.
Write that.
What's it gonna be?
2100.
2,100. So it was 2,800 and you're going all in and you were 37, 38, and you're going for 21. All right, here's final Jeopardy question. I'm gonna give you 30 minutes. Don't present your answer until 30 seconds, sorry. Don't present your answer until your 30 seconds is up. Are you ready?
Ready.
Who's Alan?
List 5 signs that a chemical reaction has taken place.
Quick question.
Yeah.
Because no matter what, if they get it right, they win. But because they're just gonna do whatever we do plus one. So like, just to beat us by 100. But if we get it right, we do another question so we can get literal.
You're 16 seconds into your 30.
Michael,
Good question yet.
Yeah, I did.
Changing color.
Said what were the, give 5 signs that the chemical reaction has taken place. 25.
Color, temperature, sound.
And stop. Okay. What's your answer?
I have
Okay.
change of color,
Yeah.
change of temperature, creation of light, the evolution of gas, and sound.
Okay, those are acceptable. What are your answers?
Color, gas, precipitate, temperature, what else did anyone else write?
I got odor, temperature.
Yep. All right, good. So everybody got that right.
They didn't say sound.
Don't have to. There are 7 possible. I only needed 5.
Yeah.
Good job. So you guys, what did you end up with? 38 and 21.
Yes, so that
Right.
would be 59,000.
Exactly.
100. 100. No, yeah, and then you were 20 and 28. So that's 36.
Oh, they were at
56. 56. Yep. All right. Good.
I got a question.
Excellent.
I got a chemistry question. They don't know the answer of.
What?
What year was Dmitry Mendeleev born?
Oh my gosh.
I don't know it either. But you know.
Oh, okay. I don't know it either, he says. All right, so now we're going to play one other game. And this is a game where if you break my stuff, I'm not going to like you anymore.
I don't know.
Well, that doesn't
So-
apply to me though, right?
Right. Okay, so this is the toss trivia. Toss trivia. Remember, we've done this. So this is, listen, Michael and Ethan, we don't knock over lamps and we don't hit the fan. Michael and Ethan. I called you out because y'all don't remember Michael and Ethan knocking over my lamp last year and my antique microscope lamp.
I do remember.
I remember it. So this is a gentle, oh, and I'm gonna turn the fan off just in case, but we're going to gently toss. Here's how it's played. Walk. Wherever your right thumb is closest to is a number. You read me the number, and I'm gonna read you that exact question.
Why are we doing
Exact
these?
question. There are 30 questions on your test,
Can we
to be
limit
specific.
context? No.
30 on your midterm, and they are as such, just so you know. Oh, hang on, that's a junior, so you don't need that.
No, we'll take the juniors.
You don't need the juniors.
Ooh, good.
But hopefully they're questions.
You like the one?
Yeah, one second.
The old ones, they're like, ooh. I don't know, I like that funny.
All right, so there are, listen, there are 35 that are either multiple choice or true or false. Of those, hang on, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So there are 25 true or false, 25 multiple choice, 10 true or false. Then there are, let's see, there is a diagram, 2 diagrams to be exact, a couple little conceptual balancing, and then there's matching, short answer, that kind of thing. And there is a bonus question on here. Now, the only one I'm not going to give you like exact, I may not give you, let me see, hang on. If it's one of the multiple choice, one of the true or false, I'll give you that exact number. But if it's one where it's a diagram, I may give you a slightly different, like the same type. Like say you land on the one that's Lewis dot, I'm not gonna give you the same element, okay? Because that's way too easy, but I'll give you an element. Does that make sense?
Yeah.
Okay. All right, so I'm gonna toss, and wherever, it's going that way. I love that everyone ducks. That's the best thing ever. All right, Abby, where are we going?
25.
25. All right. 25. Sorry. You can determine an empirical formula by using chromatography, calorimetry, percent composition, or ionization. That is right. Now you toss to someone gently and they will catch. Oh, man.
All right.
Ready, Jack? Huh? 26. That's kind of random. A substance which undergoes a change in a chemical reaction. Product, catalyst, enzyme, reactant. All right, you toss. Nope, she just says nope.
Take it. Thank you.
Oh, it's 27.
27. This is random. Okay. This deals with quantities in reactions. Hess's law, stoichiometry, Lavoisier's law, gravitometry.
Can you repeat them again?
Yep. Deals with quantities in reactions. Hess's law, stoichiometry, Lavoisier's law, gravitometry.
Is that Hess's?
Nope, that would be stoichiometry. Stoichiometry is our quantities. All right,
I
who's
will
next?
throw it to one of you, but not both.
Wait, I need my right hand.
Somebody will beat something. Yeah, all
So
right.
notice you won't like beat it into a lamp or something.
Yeah, because you guys have to, yeah, because that's going to cause a problem. Okay, we're
17.
17.
Oh, no, 28. That was awesome.
To remove an electron from an atom, what is required? A nuclear charge, ionization energy, breaking a molecular bond, or electromagnetism?
I want to say ionization.
You would be right. All right, pass. Heads up.
What? Y'all. 2.
2. What is the correct scientific notation for? You want to write? You want to write? What is the correct scientific notation for the number? Oh, somebody have a piece of paper?
Yeah, what?
Okay. 3, 4. Hang on, let me get 3, 4, 5, 6.
3, 4, 5.
Yep. 0, 0.
Just tell me how many zeros.
0, 0. 0, 0, 0, 0.
Is that 9 or 6 here? That's
It is 1, 2, 3, 4, 5, 6, 7, 8.
Yeah, because it was in pairs.
8 zeros.
Yes.
8-0.
That would be
Fine.
Or I'll start
3.4
You.
and
Nice.
1, 2, 8.
Or I just throw you back onto the couch.
Alex, you need to press.
That times 10 to the 11.
Yes. 3.456 times 10 to the 11th. Excellent. All right.
Okay,
Gentle
y'all,
toss.
Somebody else catch the ball. It's kind of hard.
Yeah, let him catch, Jack, so we don't have a fight. All right. What do you get? 10. Number 10. There are 6.02 times 10 to the 23rd atoms per.
Ball.
There you go. Before I even give him. All right. Mole. All right. Who are we passing to?
Give us the one.
All right, Jack. 12. All right. Every orbital in a subshell is singly occupied with one electron before any one orbital is doubly occupied. Is this Hund's rule, Pauli exclusion principle, off-bow principle, or photoelectric effect?
Could you read
Ooh.
the question again?
Yes. Every orbital in a subshell is singly occupied with one electron before any one orbital is doubly occupied. Is it Hund's rule, Pauli exclusion principle, off-bow principle, or photoelectric effect?
It's either A or C. Oh.
Is that how you pronounce that too? Off bell?
I'm gonna go with C.
You should have gone for your other one. It was A, Hund's rule. Hund's rule. If you don't have Hund's rule on your study list, write it down.
Hey, it's 100.
It's Hund's rule. Off-bow is similar.
What?
19.
What do you have? You have it? Okay.
19.
19, and then you have to pass it to someone on the other couch.
They tried. I threw it to them and
They keep ignoring it.
It's not my fault.
Okay, 19, Michael Cole, which is not a type of chemical bond. Ionic bond, pair bond, polar covalent bond, non-polar covalent, pair bond, right? Okay, and tossing. Heads up on the couch. Michael, heads up. Yes, what you got?
Well, it's a split between 13 and 25, 23. Do we have either of those?
I've got both of those.
Wait,
Let me-
23.
23. The number of units in 1 mole of any substance is equal to Gibbs energy, Avogadro's number, Moser's number, or Hubble constant. There you go, Avogadro's number. Next, Hubble constant. We did that year before last. All right, you tossing? Oh, come on. Stop.
Guys, you have to.
All right, Kai, what you got, babe? One. Number one. Okay. Which is not considered a branch of physical science. We did this earlier. Physics, astronomy, zoology, or chemistry. That's so funny. Excellent. All right. Perfect. Wasn't that your same question before? That's hilarious. You're going to get that right on the midterm. Okay. All right. Pass it to your left or right. Force somebody over there to answer. Sid's arms are crossed because she doesn't want to answer. All right, Ivy, what you got? 25. Oh, yeah, we did 25? Okay, yeah. Okay, when? 2. Yeah, 2's already done. 28. Okay, let's see. Oh, yeah, that's right. I didn't put any of the weird ones on here. I just kept it to these. All right, 28. All right, percentage yield equals, is it theoretical yield over actual yield divided by, theoretical yield divided by actual yield times 100, actual yield divided by theoretical yield times 100, chemical formula divided by empirical formula times 100, or formula units times molar mass? Percentage yield. You know it. Think about it. If you were trying to figure out how much percent, we did it. It was the lab with the fluffy water, if that helps you remember. You know? Anybody want to help her? What you got?
Is it number 2?
Yes, it was actual yield divided by theoretical yield times 100. Remember, you want your little number on top because you're multiplying by 100 to get a percent. Actual yield divided by. All right, Ethan.
I got 8.
8. Numero 8. So created the planetary model. Is that Democritus, Thomson, Dalton, or Bohr?
He created the what?
Planetary model, in quotes.
I know.
Democritus, Thomson, Dalton, or Bohr?
Was it? So the answers are Dalton.
Democritus, Thomson, Dalton, or Bohr?
Bohr?
Yeah, it's Bohr. Very good. Remember, Democritus is way back in the day. He thought they were little marbles. He called them atomos. That's where we get atoms from. Thomson is the chocolate chip cookie or the plum pudding, depending on whether you're British or you just like cookies. And then Dalton we think of for coming up with the first modern atomic theory. 3 of the 5 laws we still consider. Do you remember which of the 2 of the 5 laws we don't go for anymore?
They're indivisible.
Yep, indivisible was one, and what was the other?
I'm sure.
What?
I don't know, but speaking of astronomy.
Hang on. So one of them was that they're the smallest particle, right? He didn't understand protons, neutrons, electrons, and all the other stuff like quarks and whatever existed.
Positron.
He also didn't think they could be divided, and we know that you can split an atom, right?
Yeah, it doesn't work out.
Doesn't work out well, but
Don't
it
do
can
this.
be done.
Okay?
All right.
You can.
Yes. What was your astronomy question first, Kai? I probably don't know the answer, but
You're not ready for this. So you know how astronomy
never ready. Yes.
is on the midterm basically because that's a question.
Oh yes, just yes, that it was a branch of physical science. Yes.
Right. So keeping that in mind, don't you think
Hidden figures.
it's one appropriate chemistry, astronomy?
I love you are really pushing it.
Oh yeah. Well, I mean,
We can maybe do it for the spring. I want to get this one out of the way because it was already the one we ran past parents. So I want to. I know it's a good one. You're right. It's a
and the
very
guy that
very
played
good.
Sheldon Cooper is in it, and
Yeah.
he was a big chemistry buff.
Well, and Katherine Johnson passed away what, a month or 2 ago? By the way, did you see who passed away last night? Chuck Yeager. You know who Chuck Yeager is? Chuck Yeager was first man to break the sound barrier. And here's how it did it. A little tiny orange plane, not very big, called the X-1, and it fell out of a B-2021 bomber. You don't know? A big bomber, okay? They took this big bomber up, like 1940s, right? They had this little plane attached to it. He sat in the bomber until it was time for him to shimmy down inside this little thing that was this jet fuel propelled little plane, and they dropped him and he shot out. It's really wild. You can watch original, like first time footage of it.
And broke the sound.
Yeah, broke the sound barrier for the first time. He was 97 and he died last night.
Even more incentive to watch him figures.
Well, if you want to watch a good Chuck Yeager movie, it's The Right Stuff. That's a good movie. All right, what have you
I
got?
got 7.
Jack got 7. Number 7. Oh, known for the plum pudding or chocolate chip cookie model, is it Democritus, Thompson, Dalton, or Bohr? Now this is, who was listening a minute and a half ago?
I have it on my.
I know you know.
I'm just gonna give you a slight hint. His first name is JJ.
Thompson.
It is Thompson, very good.
Here.
All right. Who wants it? Ooh,
It's me.
be sure you watch where you're throwing. All right, what's up?
It's 14.
14. All right, this is a true or false.
Oh, man.
In 1865, John Newlands arranged the known elements by property and by order of increasing atomic mass. He noticed that patterns repeated about every 4 elements. He called this law the law of quartets. True or false? False. What did he call it?
Periodic.
Octets.
Oh,
Hey.
You got it wrong.
Yeah.
What did I do?
You did get it wrong. You got it wrong last time too. Jeopardy.
All right, Abby.
No.
8.
8. We already did 8.
Dragon.
29.
29. 29.
I don't like it. Sorry.
So there are 30 questions that we're doing today, and there are others on. I'll give you the total number in a minute, but 29. Okay, 29. There's 50 total. Okay, which determines the theoretical yield? The excess reactant, the temperature of the products, the limiting reactant, or the molarity of the products? Determines theoretical yield. Excess reactant, temperature of products, limiting reactant, or molarity of products. You would be right, ma'am. Limiting reactant. All right, over there. Bonk. All right, what's up?
It's halfway between 9, 5, and 14.
We're gonna do 5.
We're gonna do, we already did 14. We've already done 9, so 5.
5, Alex.
Envision atoms like small marbles. Was that Democritus, Thompson, Dalton, or Bohr?
Democritus.
There we go. Very good. Okay, who's got it next?
Bailey. You need to do at least 1.
He's making the executive decision for you must participate.
Bunk up.
Okay, or not. 12. Okay.
12. Oh, you already did 12. It was yours before. It was the Hans rule, yeah?
8.
Like they're like really.
Do
Actually,
you want
no,
to go check
16.
on them? I think Miss Jackie's up there, isn't she?
Oh, never mind.
I-
Jack's actually doing 21. 21.
21?
Come in.
That's already been done.
Okay. A covalent bond in which 2 atoms share 1 pair of electrons. Is this a single bond, a double bond, a pair bond, or a metallic bond?
In which 2 atoms share?
A covalent bond in which 2 atoms share 1 pair of
Can you
electrons.
repeat the choices?
Single bond, double bond, pair bond, or metallic bond.
Can you repeat those things again? I'm sorry.
Uh-huh. A covalent bond in which 2 atoms share 1 pair of electrons. Single bond, double bond, pair bond, or metallic bond. Was she here?
Yeah, she's here.
Oh my gosh.
It's like all I'm picturing is her. I was like, how do you conjugate a verb? She's like,
Pair. Single.
Single bond. Single bond, single bond.
Because
All
they're
right.
sharing a single pair of electrons.
Sydney. Participate.
All right.
Sydney? What?
Come on, Sydney.
Sydney don't wanna do it.
Come on.
I get to put her on the spot, but nobody else
Yay.
does. There we go. And Kai.
5.
What do we have, friend?
20.
20.
That was 26.
Ionic bonding
That was 26.
is a force that attracts blank
I know we did it already.
from one atom to another, which transforms a neutral atom into an ion. Would that be nuclei, neutrons, electrons, or mass?
I know it.
Okay, I did it.
Let
You
her
know
think.
everything. Be quiet.
What? Not everything.
Most things. How about that?
Confidence in you.
It's either electron, neutrons, atomic, or mass.
No, it's nuclei, neutrons, electrons, or mass. Ionic bonding is a force that attracts what from one atom to another, which transforms a neutral atom to an ion. Yes, yes, you know it. Good job. Oh, look, Cole will take it.
And after that, me.
Electrons?
You already answered everything.
Yes, electrons.
Yeah, why I want it.
I will get when you have it done before. I got 30, let's go.
All right, 30. Number 30.
I got 28.
The energy as heat needed to raise 1 mole of an element or compound by 1 Kelvin.
Say, what's that? Oh, that's the molar capacity.
Yeah, molar heat capacity. Good job. All right. Who's next?
How many do we have left?
We'll go for like 2 more minutes and then I'll go over a couple of other last minute things.
Have we done all 30?
No.
I think there's 1 or 2 you've missed, but I'll look at them before we.
Okay.
Pass it to Ethan.
I don't know who wants it.
Pass it to Ethan.
We really don't know. It's so cheating. I don't think anyone wants it. Bailey said she'll take it. Bailey wants it. Bailey wants it. Bailey wants it. Bailey wants it.
All right, Michael, what you got?
Michael got it.
29. No. 18?
18. Okay, 8.
Have you got it?
No, we did similar. The structure of an ionic compound is molecular in nature, a crystal lattice, malleable, or positively charged.
The crystal lattice.
All right, good job, good job. And let's do 1 more. 1 more.
Bailey.
Michelle.
Michael has to throw the
Who wants it?
ball for the game to continue.
I want it.
Abby wants it.
Alley-oop.
Don't you
All right,
dare
Abby.
steal it. Don't you dare steal it.
Okay, what you got? 19. We did 19. Toss and catch.
Is it 4?
We did 19?
Yeah.
It was still in the.
Yeah.
25? We did 25.
25. We did. You did. 29.
That provides.
You did that one. That was yours.
Oh, it's their final one.
13. I think that's a new one. It's on the page.
Oh, just questions.
Okay. True or false? Your independent variable
No.
is what you keep the same.
That was it.
What number?
False. What is what you keep the same?
You're a control variable.
Very good. Okay, here, pass the ball back. Nice. I never catch anything. All right. Okay, couple ones. Let's see. Let me just throw a few more at you. Make sure we covered everything.
Standing.
Yes.
Speaking of hidden figures, I love your skirt.
Thank you. It's one of my many Spaha investments. I am in love with that designer and everything there. It's all geeky. Did y'all not notice it? She's the only one that noticed that I'm wearing chemistry gear.
I thought it was.
We noticed it.
I have a bunch of these. I just got one recently with
every
fractal dragon scales and another with dragonflies and love it.
What?
Alrighty then. All right, let's see. You did that one. You did that one.
Yours was like the hidden meaning of the direction.
What? How about let's do it this way. If you know it, throw your hand up.
His fingers.
And atom with a different number of neutrons. And Abby. All right. Let's see. The modern atomic model is called the Alex
I believe it's quantum.
quantum. That's what you want.
Just when in doubt, just think about like every sci-fi movie and they're like quantum physics. I don't know.
How about we did Mendeleev earlier? We did that one. Some of these we've done in different forms. So, all right, we did that. We did that. Did that. Oh, I love it when we've done all these.
Cold.
We did that. Okay.
It wasn't funny the first time.
I think we did this one. Bond that occurs when electrons shared by 2 atoms are held more closely by 1 atom, Ethan.
Polar covalent.
Yes.
Chill. No,
All right. How about,
You two should get married.
that's not true.
no, there's so many. We did that. What deals with quantities and reactions? I know we did it, but not everybody got it. Alex?
Stoichiometry.
Stoichiometry. Did that, we did that. Okay. True or false? Q equals heat.
False.
True. Q equals heat. Very good, very good. True or false? Delta H equals entropy.
False.
Think. Think.
No, enthalpy, not.
H is enthalpy.
Delta H equals entropy. True or false?
I think it's false.
False.
Yeah.
Why?
Because H equals enthalpy.
Yes, good. Pay attention when you see ones like that.
And
Oh, Alex, don't tap too loudly. That's my mother's head below you. All right, the standard enthalpy or enthalpy of formation is equal to the boiling point of a substance. True or false?
What did you say? I don't think that's true at all.
They must love
Okay,
you.
we know what you think.
The
about
standard
being
enthalpy or enthalpy of formation is equal to the boiling point of a substance. True or false?
I'm gonna say true.
This isn't note checking. People are not.
Wait, can you read it one more time?
Yep. The standard enthalpy or enthalpy of formation is equal to the boiling point of a substance.
That's what I said.
I can see that going either way.
I'm gonna say false, not just because he said it really loud.
But I think that's false,
specifically,
yeah.
I'm
But
ahead with
that
that
just doesn't sound.
Midterm.
Yeah, there's a
It's
small-
false, it's freezing. Think about it. Your formation, think about it that way. Okay?
for example, here. there's a
All right,
small-
true or false? In a decomposition reaction, binary compounds typically break down into two elements. True. Remember to throw your hand up and not answer before everybody. All right. A measurement of the degree of order within a system is its enthalpy. True or false? Oh, Ivy, that was your hand.
No,
I was just being.
A measurement of the degree of order within a system. Yes, Ethan. Is its enthalpy true or false?
I'm pretty sure that is. Pretty sure it's false.
That is
I
right.
am so smart. It's entropy.
Entropy, you got it. Okay, good. What's the experimental measurement for enthalpy? What's the experimental measurement for enthalpy? How do you measure enthalpy experimentally? We did it last week.
No.
Calorimetry. Calorimetry, we did it last week. All right, now, here are some ones that are not multiple choice and that are not true or false. So these ones you have to think about.
Essay questions?
Some of them are more like identifying things with elements or filling out, Okay, how about this? You guys got your prefixes, right? Your metric prefixes down and memorized?
Yeah.
You sure you have them down and memorized? All right, now, can you do a Lewis dot diagram?
No.
Yeah.
Do you remember how to do it? Go home and practice some Lewis dot diagrams. You gotta be able to do one. They're not hard. The little guys can do them. They're not hard.
Okay, were those the ones that are on the test last year?
No.
No. Your Lewis dot diagram is you take your element and then you draw dots around the outside of it in pairs.
I'm thinking of the dot thingies, the ones that I struggled with because I know what independent and dependent and manipulate variable was.
Right on.
That thingy was just.
I don't know what. Oh, you're talking about the little. Oh no, they're right next to them. I'll show you blurrily what it looks like.
I tried
All right.
really hard there for a couple of seconds.
How about? What if I asked you how many valence electrons sulfur has?
Off, Michael, you got this.
Do you know?
Sulfur
I believe it's six.
Yep.
It goes in this area.
It's 6. Yep.
It's just concerned.
You will have a periodic table stapled to your
I
test.
know why, because it's in the 6th group.
Yeah, it's.
Yep.
What is?
Yep. Let's go, Alec.
What's the chemical formula for? Oh, here's a tough one. What's the chemical formula for cobalt-2 bromide?
Is that on the test?
Oh, it might be cobalt-2 bromide.
I have a question.
Uh-huh.
You said we're gonna have a periodic table attached to it,
Yes.
right? Okay, making sure.
Wait a minute.
One
what?
I'm not missing.
Cobalt-2
BR2.
bromide. COBr2, right.
CO.
And what do we call O2?
Oxygen, gas, oxygen.
Oh, I'm sorry. Let me be specific. O superscript 2, not subscript. O with the superscript of 2. What is that? Yes, that's oxide. Good. All right. What if I gave you hydrogen and nitrogen? I'm just going to throw out 2 and asked you for, actually I can't do that. That wouldn't work. Hold on. Yeah. Okay. Nitrogen and oxygen. And let's just, no, hang on. I'm trying to make one that's not too complicated. I don't want to give the exact one. So how about carbon and oxygen is what? CO is what? Carbon monoxide. What if I asked you for its mass in, what if I asked you for its mass of a mole? How would you get that?
You take the 2 AMUs now together.
I want
Okay.
to say it's 28. Around 28.
That means atomic mass.
I want to say
Yeah,
it's around
he's right.
28 grams.
Yeah, so you take all the AMUs together.
Take all the AMUs and do what?
Add them together.
Add them together, right? Okay, now what if it was carbon dioxide?
Then you take
CO2.
You take 2 oxygens and then 1 nitrogen AMU and add them together.
Not nitrogen.
That is you mole.
2 oxygen, 1 carbon. No, that's what I asked. What was the mass in grams of 1 mole? So
Of
that's
1 mole,
right.
okay, yeah.
Okay. What if I gave you, you guys have lost your minds. If I gave you a compound and asked you, and I gave you the compound and you have all the molar mass and everything, how would you find the percent composition of that? Like, so let's take our CO2, for example.
You multiply together your the subscripts and the mass, and then you divide that by the total mass. Multiply that by 100. to get the percentage that the-
How about let's do this. Let me throw it up real quick. Let me
Formula for it?
no, I want to make sure everybody understands how to do it. Hold on.
Oh, I remember doing it in class, but I don't remember like the step by step.
Right. Okay. So let's put this up. Let me go back to, is Shannon still with us? Yes, she is. Okay, good. Let me share. Whoopsie. Whoops. Go, I can't see the thing. Over here. So crazy. 1 second.
I don't know. It just
All right. So if I did this and I got to put it back up there now. What's the matter?
I don't know.
Are you surviving over there, Cole? Do you have problems? Do you have problems?
No,
Now you do.
It's like a hot potato. You put it out in my lap. Like I don't.
Yes.
Would you like to share?
Right, hold on 1 second
No.
here. Oh, Shannon chatting with me. Shannon says, yep, still here.
Yeah, go ahead.
Oh, Shannon knows when Dmitry Mendeleev was born, according to her chat. She says February something of 1834. February something. All right, I'm throwing this back up.
Why?
Oh, do you not want to know that?
No. No.
Internet.
All right, do it this way. So let's watch here for a sec. I'm gonna put this up here. Oh shoot. Hey Cole, is my stylus in my bag there, the little zipper bag? So it's much easier to use my stylus than to use my finger on it. Okay, let's try this.
Oh, this is how.
Is it in there? Thank you.
Why does it?
Here.
Like,
All right, so say we have,
just.
make sure you guys remember all this. Okay.
Remember all of what we're about to see?
Yeah, I'm gonna put it up. Well, I'm gonna make sure that you guys remember. Oh, where's the annotate? Can I get a board? How do I get that whiteboard thing again?
Oh, what is this?
One. That's what I thought. Yeah, I have to stop this and then I have to do it. Where is it? Oh, that's right. That's right. There it is. Thank you, Bailey, for reminding me. I don't do that often enough. Okay. Say we have, of course, the last time I tried to write in this, it was crazy too. So CO, shoot, there we go. See, it doesn't do the eraser and that's what makes me crazy. All right, CO2, right? What's the atomic mass for carbon? Roughly 12. And then what's the atomic mass for oxygen? 16 and 16, because there's two of them, correct? So what's our total?
44.
44. 16 and 16 are 32 plus 12. Okay, we good with this? Okay, so you with me? Some of you are not. Okay, so here's our total. So how
AMU of that equation?
So look, we have 12 here and 16 and 16 are 32 here. So we want to know what percent, if we want to know percent composition. All right, so this is the whole, right?
Yeah.
And these are the parts. So if we want to know how much carbon we have, we do this, right?
Yeah.
And then what's, anybody want to, Alexa, what's 12 divided by 44?
I know your answer. I know
12
the
divided by
She's
44
slow.
is approximately 0.2727.
Okay, so 0.27, so we got 27%. Okay?
0.2.
And the other has to
No, it would be before times 100, it would be 0.27. But once we've multiplied it, we're 27.
27.27.
So the other one, what are we looking for it to be? 63-ish, we're hoping. Okay, so let's do the other one. 32 divided by 44. Alexa, what's 32 divided by 44?
72.
Oh.
Not 61. 72.
32 divided by
Yeah.
44 is approximately 0.7273.
Okay, 7273. So we'll go with 73. So that's we got. That's 100, right? 27 and 73 is 100%. That's the whole thing.
Yeah.
So that's how you do that kind of problem.
Yeah. Okay.
Okay. All right. I have to be very careful what I open now because you people are looking up there and everybody's looking. I don't want to. No, I'm not going to throw that up there. Trying to think. So that one you could do. Okay.
We'll probably forget it by the time we take the
Y'all can
test.
balance really well, right? Everybody's good at balancing?
I can balance well.
I am
Okay.
bored at balance.
Let me try to think.
What is it? Hey, don't do that.
Okay, let me stop share for a sec.
No.
Let me look one more time and see what else I need to go over.
Ethan has a great personality. Thank you, Paul.
Yeah, these guys.
Dad jokes are supreme. Thank you. Yeah.
Okay, we did that hypothesis.
Well,
Know those 5 laws or at least be able to match them. Cole, did y'all hear me? Know the 5 laws or at least be able to match them. Okay? You know what I mean when I say that?
Laws of what?
5 laws of stoichiometry, the 5 major laws that we were dealing with. All right, I'm going to do like this. And I'm going to toss this over here. And now I'm going to, okay. Let me go back to sharing again. Ozzy, I know I'll let you out in a second, buddy. I know. Okay, we're going to share screen and I'm going to go back to putting you guys back up on the TV. I should have printed something out, but this is going to be easier. So, all right. I have to do it every time like this or done like that. All right, so let me show you something you might see that you need to understand how to deal with. All right, so say you are presented with, are you with me, guys? Say you are presented with this. What is this?
Single displacement.
B and C, right? Is that A plus B times C equals A times?
Single displacement reaction.
Yep. So this is a single displacement because A has switched places with B. Do you see it?
I believe that means.
All right, so wait. Let somebody else answer the next one. Let a hand go up. Okay, let's not just blurt it because that's going to make it harder for people to have an opportunity to play. All right, so what's this one? Abby, what's this one? That's decomposition. Very good. Okay, how about, let me make this one bigger so we can see it. What's this one? Michael, is that a hand or a yawn? That's a hand. What is
I
that?
thought I knew it, but then I think I don't know.
No, you do.
So no.
Bailey, that's combustion. There's a flame there, so you know that one's a giveaway. All right, what is this one right here? All right, Alex. Synthesis. You see why? All right, and lastly, all right, Abby, what's this one going to be? Double displacement. Do you see why? A and B here become A and D here, and then C and D here become C and B here. Everybody sees that?
Is that synthesis?
This one is double displacement. Do you see? Okay. All right, you have 10 minutes till Spanish. I will let you go, and if you have any specific questions about the midterm, ask me, but I think we covered almost all of it except specific problems. It's just a bug, y'all. Good gracious. Okay, doke. I'm gonna disconnect here because I don't want you looking at. All right, Alex, we're good. And I'm gonna disconnect over here. Shannon, thank you for joining us, hon. Whoops, let me come back over here. That should go away. All right, Shannon. Good to see you. Thanks for joining us. Oh, wait, she's got a chat thing. Can't balance well. Oh, sorry about the screen. Okay, go back to the marshmallow tutorial. I'll make sure I share that. Okie doke. See you later. And the screen you missed. No. All right.
We're going out.
Later.
Basics.
Bye.